on Facebook on WAEC Online Chemistry. Are you a chemistry teacher teaching in secondary school? If you are a student and not having E in chemistry in WAEC, it means that there is something wrong. That is why this channel is very, very important for you to follow. Just subscribe to this channel for the latest update on anything about chemistry and biology. Now, we have already look at let's take a, this is practical chemistry, so a predicted question. We have already predicted questions on salt analysis. We have already looked at our endpoint. If you are watching this channel for the first time, just go to my YouTube channel. You will see everything about chemistry practicals, volumetric analysis, which involve this one, salt analysis, that is qualitative analysis, which involve analysis of salt, and so on and so forth. Then the next video we are going to make is predicted test of chemistry. That is do you know that, let me shock you, do you know that if you pass chemistry practical 60/60, you are sure of what? Of D. Just chemistry practical alone can give you a D. Now this question alone, titration is about 22 marks, salt analysis about 24 marks, and test of chemistry maybe 12 or 14 marks. So it gives you a total of course you can do the analysis. Now if you know you have problem in calculating all these parameters in titration, I am organizing a tutorial. Okay, I am organizing a tutorial. Look at my phone number here. Friday, Saturday, before Tuesday of the exam. So just do where to hit me up on the WhatsApp. This is my WhatsApp number. You can chat me up to calculate. So whatever whatever one that comes, you just know that you are good to go. You just go and teach your students so that you don't have problem. Chemistry is one of the simplest subjects that you can ever think of. Now let us look at this question without not wasting time. Okay, without not wasting time, let us look at this question. This is how WAEC 2025 question that are predicted will come, and this is the format. Now say A is what? A is 0.103 moles per dm cubed of what? HCl. B is a solution of what? Sodium hydrogen triazocarbonate of what? Of unknown concentration. They didn't give the concentration of this one. Put A into the burette and titrate it with what? With 20 or 25 cm portion of what? Of B, using what? Methyl orange as what? Indicator. They might decide to give you methyl red. Okay, so but yeah, we say that methyl orange because of what? Is strong acid against a weak base. Strong acid against a weak base, you use what? Methyl orange. When it is strong acid, weak acid, strong base, you use phenolphthalein as indicator. So this one we are asked to use what? Methyl orange as what? Indicator. Repeat the titration, right, to obtain what? Concordant titer value. Tabulate your reading and let us fast forward. We say from your results, calculate what? Concentration of what? B in moles per dm cubed. 2. Concentration of what? B in grams per dm cubed. C, that is 3. Volume of carbon dioxide at what? STP. Why they will give you volume of carbon dioxide is that from the equation here, when this hydrochloric acid react with this salt, this acidic salt, it will liberate what? Carbon dioxide. So they will ask you to calculate what? To calculate the volume of carbon dioxide that is what? That is evolved. Do you get that? So this is the predicted question, but I will show you in case they give B as here, it is A that is in this one. I will teach you if that it was asked, maybe if that is concentration of A in moles per dm cube, I will teach you how to get the concentration of A per in moles per dm. Do you understand? So take a look at this question, peruse through it. All right, now let's begin our solving. Remember, in the equation, let us bring our equation. Look at the parameter that you need to, when you are asked to do this kind of calculation. First of all, put down your parameters. Now A, CA is given in what? Remember, they say that A is a solution of what? A is given as 0.103 moles per what? Per dm cubed. That is your what? That is your A. Now volume of A, VA, is equals to what? We have done our practical. done our this thing, our endpoint for 2025 WAEC is what? We have said that it is, maybe I'll take my own to be 23.10 cm cubed. Do you get that? That is volume. Now volume of base VB is equals to what? 25.00 cm cubed. Now where do I get my 25? Remember, they say that I've titrated using 20 or 25 cm cubed of what? Of base. That is what you use in pipetting is 25. So our own, the one you use in the laboratory is mostly 25. So volume of base is what? 25. Go back to the question and go and check that that volume of base. Now we are asked to calculate. Now we have CB in what? In moles per what? Per dm cubed. Are you following? CB in moles per dm cubed, and what? In CB in what? In grams per what? Per dm cubed. These are the two things we are asked to calculate. Now, since you have given this, let me tell you, there are two major formulas used in calculating this moles per dm cubed and grams per dm cubed. Two major formulas you can use to calculate that. Now, two major formula you can use to calculate moles per dm cubed, and only one formula you can use to calculate what? Problem in what? Grams per what? Dm cubed. Is that understood? Now, for moles per dm cubed, let me just state the formula. For moles per dm cubed, there are two formula. One of the formula, one, we have molar concentration is equals to mass concentration all over molar mass. This is one of the formula you can use to calculate what? Concentration in moles per dm cubed. The second formula is CAVA all over CB VB is equals to NA all over NB. This is what? These are the two major formulas that you can use in solving concentration in moles per dm cubed and concentration in grams per dm cubed. Is that understood? So for grams per dm cubed, this is the only formula you can use. While for moles per dm cubed, you can use this formula or you can use this formula. Now the problem is, where can I use this formula when you are asked to calculate the concentration of concentration in moles per dm cubed? Since the two formulas are always used, so when can I use this one or this one? Now let me reveal the simple secret. That is why our tutorial that is coming on Friday and Saturday, we are going to unveil the secret of calculating all the parameters in chemistry titration, so you can't afford to miss it. So look at the phone number here, just chat me up. This is my YouTube channel name. Chat me up. You will see we are going to organize this, and it's going to be fun and very, very interesting and educative. So now look at, now I told you that there are two formulas you can use to calculating concentration in moles per dm cubed, whether it is of acid, whether it is of base. These are the two formulas. Now what for grams per dm cubed, this is the only formula. Mass concentration is in grams per dm cubed, while molar concentration is in what? In moles per dm cubed. All this one will be treated in our class that will be holding from Friday and Saturday. So mass concentration is called what? Grams per dm cubed. That is the unit. While molar concentration is what? Moles per dm cubed. Molar mass is what? Grams per what? Per mole. Let's proceed. You know that concentration here, you are asked concentration in B, concentration of B in moles per dm cubed. Anytime, listen very, very attentively. Anytime you are asked to calculate concentration in moles per dm cubed, and one of the, remember we have the one of acids and we have the one of what? Base. You get that? Anytime you are asked to calculate concentration in moles per dm cubed, and one of the concentration, remember concentration in moles per dm cubed is a molar concentration, and one of the concentration is already given in the question. If acid is given in the question, you don't need to come and use this formula. Do you understand? If you are asked like now, acid is given in the question, the concentration of acid is given in the question, and now you are asked to calculate concentration of base in moles per dm cubed. Since acid is already given in the question, you go direct and use this formula. Do you understand? But if acid is not given in moles per dm cubed, Do you understand? Base, they are not asking you to calculate base concentration of B in moles per dm cubed. You must go and use this formula. Do you understand? Sometimes they will ask you, they will not even give you, they will ask you to calculate the concentration of B in moles per dm cube, calculate the concentration of A in moles per dm cube. It means that you have to use one for acid and use one for base. For all this explanation will be done in our class, so just you can't afford to miss it. Friday, look at the phone number here, just chat me up. Now this one, now look at the concentration of acid here is given in the question. Go back to that question, just scroll back, go back to that question. It's given in look at the concentration, 0.10 moles per what, per dm. It's already given in the question, so we don't need to come and use this formula. We need to use this formula for this question. Do you understand? We use this formula for this question. Then you now come and use this formula. Since this one is the only formula you can use for this one is this one. This one does not have any other formula, unless it is given in grams per cm cubed. We are going to look at that. Grams per cm cubed, you need to divide this one by the volume, which we are going to look at that. So this one only have one formula, and this is the formula. Do you get that? So this one, having discovered that we are going to use this formula, we just go direct to our calculation. Do you understand? I repeat, we are saying that, listen, we are saying that this calculation in moles per dm cube, you can use this formula and this formula. The only time you can use this formula, this one, is when one of the concentration is given in what, in moles per dm cube. In the question, look at, in the question we have what, Ca as our 0.10 moles per dm cube. So since in the question they have already given us this one, we go direct and use this one. Do you get that? We go direct and use this one. There is no need of using this one for what? For moles per dm cubed. Then this one, I told you, that has only one formula. This one is you use this one. So having looked at that, let's go back and solve out. Remember, the equation is the equation for the reaction is, let me write it here. The equation, let me write it here. We have HCl plus NaHCO3 will react to give you NaCl plus H2O plus CO2, carbon dioxide. Now I told you that our endpoint has already been determined. If you are watching this video for the first time, just go to Ojema YouTube channel. Our endpoint is what? 23.10. Okay, now we'll use this formula to solve this first one. Do you get that? So now this first one is what? B. Concentration in what? Concentration in what? In moles per what? dm cubed. So we are going to make this one the subject of formula. So we say Cb is equal to, when you remove this one, look at, you cross multiply. This one that is higher will be on top, while this one is lower will be down. You get that? Cb will now be what? Look at, we have CAVANB all over what? All over VBNB. Is that understood? This is our formula for this one. Now remember, we are calculating this one. Now we proceed. CB now is equals to, what is your CA? CA is given as well. Look at your CA here, 0.103 multiplied by, what is your VA? Volume of acid. VA is what? 23.10 times, what is your mole ratio? Mole ratio is, this is acid, this is base. You get that? What is in front of this this base? What is in front of this acid? Nothing is in front. So the mole ratio is what? 1. The mole ratio of acid here is what? 1. You get that? If 2 is here, a mole ratio could have been what? 1:2. But since nothing is here, is what? 1. And since nothing is here, is what? 1. Do you get that? If acid here has 2, for instance, it would have been what? 2:1. But since there is nothing there, is what? The ratio is what? 1:1. Are you following? Now you multiply by what? By 1 over your VB. What do you have? Your VB is what? VB is, look at 25 times your NB, base, your mole ratio of base. This one is called mole ratio. Mole ratio of base, what? 79 all over 25. CB is equals to, divided by 25. is equals to 0.0995 moles per what? Moles per dm cubed. That is our answer. Do you know that when we use our, go and watch that video, how to determine endpoint. When we divide the molar mass of what they have given to dissolve in water before the titration, divided by the molar mass, you have this answer. So if you don't have this answer in what WAEC will give you and this answer in what WAEC will give you, it means that there is something wrong. Is that understood? There is something wrong. So this is the answer you are expected to have in your calculation. Teach your student on how to master this solving. Is that understood? The next thing, now we are done with this one. Are you done? Let us proceed. We are done with this one. Now let's go to concentration of B in grams per dm cubed. Concentration of B in grams per dm cubed. I told you that in grams per dm cubed, this is the formula that you use. Do you get that? Sorry, we have gotten our this CB now is equals to, in moles per dm is 0.09. What do I have as the answer? 0.95 moles per dm cubed. I don't know why that is. Okay, let's just take it like this. Moles per dm. We have gotten our CB. Do you get that as our answer? Now let's use this formula. Now I told you that concentration in grams per dm cubed is called mass concentration. This is mass concentration. So we are going to make mass concentration the subject of formula. Mass concentration the subject of what? Formula. You see, mass cons of B in grams per dm cubed is equals to, look at, cross multiply, this one will come first. You say mass is equals to, when this one is the one replacing this one, so you are going to what? Cross multiply. This one will come here. You say molar cons multiplied by molar mass. Anything that you are doing is your B. This is a, but don't always use the molar mass in the equation. Use in the equation, use the molar mass in a question, because sometimes the mole ratio, you can mistakenly use the mole ratio here in the equation and calculate your mole, and you have a fake answer. So use the one that is given in the equation, not the one in the equation, because in the equation you might have a mole ratio. Do you understand? All this one will be treated in our tutorial, so just avail yourself that opportunity. So we are going to look at the molar mass of this one. So but molar mass of NaHCO3 is, we have N is what? N is, our molar mass is 84. So what we now have is that, remember, you are going to mark what is your molar concentration. I told you molar concentration means moles per dm cubed of B. Look at it here. So we are going to say that no, let me wipe. Take this one. So we have, let me take this one. So now we say that our molar concentration is what? 0.095. You multiply by what? Your molar mass, you just had 84. So it's 7.98 grams per what? Per dm cubed. So this is what you are expected to have at the end of your calculation in what? Concentration of B in grams per dm. It's very, very necessary. Just go and teach your student this calculation that I'm doing. If you want more knowledge, maybe I'm organizing this class on Friday, that is weekend. By then you are settled. Friday, Saturday, so that the exams is on Tuesday, so that Monday as you go to school, teach your student on how this thing, or those who are in boarding school, just use that avenue and teach them. Is that understood? Now we have gotten our this one. Now volume of carbon dioxide at what? STP. Remember, I told you that they will ask you volume of carbon dioxide because of what? When this acid react with this base, of course this one is classified as base, will give you what? Will liberate carbon dioxide. So they will ask you the volume of what carbon dioxide that is what liberated. Do you understand? So now, having done this, let's go back to 1 mole of N. The carbon dioxide is coming from here. Remember, we have the reactant, we have the product. This carbon dioxide is as a result of this particular thing. So 1 mole of NaHCO3 will give you what? Will give you 1 mole is that nothing is here. If that is 2 mole, if that is something is here, maybe 2 or 3, would have said 3 moles of. Do you get that? But since nothing is here, it is what? 1 mole. So 1 mole of this will give you what? How many moles of carbon dioxide? Nothing is here in front of carbon dioxide. Is what? It says give you 1 mole of CO2. Do you get that? Now you now go again. But 1 mole of NaHCO3 will produce so 22.4 dN. So therefore you have 0.095 times 22.4 is equals to, so you have what? 2 expected to what? To get. For more of the parameters, I am holding a seminar, or let me just say tutorial, beginning from Friday, Saturday. So just do well to chat me up on this number, so that I can teach you all the parameters you need to know. But what